Guys, we should have split this up into two figures. I'm going to label mine figure number 1 and figure number 2. Number 1 will be the prism on the bottom. How do you know it's a prism? Because what? How do I know this is a prism? There's no curves, okay. And? Yeah? What? It has a base of a square. And does it have 2 of those bases of a square? Yes, okay. That makes it a prism. If it has 2 bases, okay, and then segments that are connecting them that are the height, that is the definition of a prism, okay? It's got 2 bases, one on the top, one on the bottom, okay? And those bases happen to be squares. Let's find the area of figure number 1 first, which is that prism. So I said area, I meant volume. The volume for a prism is the area of the base times what? The height, okay? Now, what is the base of this prism? What shape is it? It's a square. It's 4 units by 4 units. Do you guys see that? So how do I find the area of that square? I multiply 4 times 4. Do you guys agree? So what's the area of the base? 16 inches squared. Do you guys agree? Cool. So the area of my base, my capital B, is 16. What's the height of the prism, though?
4.
It's 4. So we have inches squared times 4 inches. That means I multiply 16 and 4. What do I get? 64 inches cubed. I just found the volume of that prism on the bottom of my figure. Now, the second figure, change your color so you can see the difference. And we already agreed this was in the shape of what kind of figure? A cylinder. But it's not a full cylinder. Do you guys agree?
No.
It's like half of a cylinder. So we're going to take the volume formula for a cylinder. Who remembers the volume formula for a cylinder? Yeah, Christian? Very good. Times the height. But we're not going to use that formula. What are we going to do with this formula? Divide it by 2. Because we're dealing with half of a cylinder. Okay? All right. The second tricky part was, what is the radius of this cylinder? Christian? Why is it 2? Correct. This length here, guys, is 4 inches. And if you want half of it, it would be 2 inches, okay? So the radius is 2, so R is 2. What's the height of the cylinder? From one base to the next base, how high is your cylinder? From one semicircle to the other semicircle, how high is the cylinder?
4.
It's 4 inches, okay? This length is 4, and this is your height. So my height is 4. Plug those in. Let's see what we get. So we get volume equals pi times radius squared. What's 2 squared? 4 times 4 again, and then over 2. So this is going to be pi times 16 over 2, which is going to be 8 pi. And when you plug it into a calculator, I believe it's 25.1. Let's round it to the nearest tenth. Let's say it's 25.1 inches cubed. How do I find out the total volume then? What? You add them together, okay? So when I add them together, that'll give me volume of the total thing. And that will be 25.1 plus 64 gives me 89.1 inches cubed. Talk to me. What questions do we have? We're okay? Yeah, Cody? Where'd I get 16 inches squared? Okay, so for a prism, right? You take the area of the base, and that's what I was doing for the area of the base. It was a square, so I just multiplied the side by itself, 4 times 4, and that gave me the area of this base down here, and then you have to multiply it by how high it's going up. So that's why I multiplied it by 4. Got it? What other questions do we have? Yeah, Scott.
So you go
25.1. Juliet?
Why would you divide h by 2 as well?
So the entire thing gets multiplied by 2. Technically, Juliet, you only have to multiply one of those values by 2 because they're all being multiplied by one another. If there was addition in there, if it was like 6 plus 4 and we're putting that over 2, you have to divide both terms by 2. But if it's 6 times 4 over 2, you can just cancel out this 2 with one of your values, right? So this would be 3 times 4, which would be 12, okay? This one you'd have to cancel out with both. It would be 3 plus 2, and that would be 5, okay? So when it's addition, you have to cancel out with every term, almost like distribute that 2, and when it's multiplication, just cancel out with one of them, okay? Good questions. Any other questions from the warm-up? Nice. Okay, take out your homework from last night, which was big. So this is chapter 11, section 6. Guys, we'll have a test on this next Wednesday. All right, it'll be on 11.4, which was just the polyhedron thing. You guys all really like that lesson. 11.5 and 11.6, okay? 11.6 is all about the volumes of pyramids, okay? Now, I want to show you a little example, okay? So look at the figure on the very first slide. The box, right, that you guys see on the outside, that's an example of what kind of shape? A cube, also known as what more general shape? What have we learned about? Starts with a P. Very good. It's a prism, okay? It's a prism because it has how many bases? 2 bases, okay? Now, the shape on the inside is what? It meets all at one point. It's a pyramid, okay? Which one would you expect to hold more water if you were to pour water into each of them? The pyramid or the prism? Why would the prism hold more water? It's bigger, right? It's not meeting up at a point. It's continuing. It's like a box, right? If you were in a race for who could like carry the most water with them to like, I don't know, or drink the most water out of this, you would pick the box. You guys agree? You would not pick the pyramid? So when we're talking about volume, I want you to pay close attention to the formula when we write down the formula for volume of a pyramid, okay? All right. So the first thing we're going to talk about is something called a regular pyramid. Regular pyramids have one base, and it's a regular polygon, okay? A regular polygon, remember, has all congruent sides, all congruent angles. All the lateral edges are congruent to one another. All the lateral faces are all the same, and they're all isosceles triangles. And lastly, your altitude will meet the base at its center, okay? These are regular pyramids. Okay. Now, the volume of a pyramid has the following formula. It's V equals 1/3 capital B times H. It's the exact same as the volume of a prism, but what's added? It's 1/3. Now remember, is multiplying by 1/3 going to make your volume smaller or bigger? Smaller. And we agreed that pyramids were a bit smaller than prisms, correct? And they're related by 1/3, okay? So 1/3, the volume of a prism is the volume of a pyramid, okay? And this is the only formula that you'll need to know for this whole lesson, okay? 1/3 base times height. Now, the base of your figure is the base of your pyramid, and that's area. And then height is the height of your pyramid, okay? How tall does your pyramid go, all right? So if we're looking at this figure, the height is that green line that's perpendicular to the base and goes to the top of your pyramid. And your base, your capital B, is the base down here. It's the area of this rectangle or square, depending on what its dimensions are. All right, let's do some examples, okay? A regular square pyramid has a base edge of 6 centimeters and a height of 12 centimeters. find its volume and give the exact answer, okay? All right, so let's do it. We've got a regular square pyramid. So what shape is my base? A square. So draw a square. I would slant it a little bit so it's easier to draw the pyramid. But we know that in a square, all the sides are congruent. Do you guys agree? Cool. And then it's a pyramid, so draw a point up on top and connect each of the edges of each of the vertices of the square to that pyramid, like this. And we've got a nice little pyramid. You right there, Dylan? You can't draw it? You're trying? Okay, so draw like a square-ish figure. I slant mine so it looks more three-dimensional. And then draw a point above and connect all the edges to it. Yeah, looks pretty good. Okay? All right. Now, the base edges of the pyramid are how many units? What did it say? 6. So all 4 of these are 6 units. And the height of the pyramid, change your color and draw the height of the pyramid. It goes down and it forms a 90-degree angle with the base of the pyramid. What was the height? 12 centimeters. Okay? So now let's write down the formula and see which pieces of the formula we know. Okay? Let's write down the volume for a pyramid is 1/3 the base times the height. Okay? Do we know the height of the pyramid? How tall is it? 12 centimeters, okay? So we know this one's going to be 12. Do we know the area of the base right now? No. So we're trying to figure out the area of the base. Once we figure out that, then we're fine. Our base is what shape? A square. And how do you find the area of a square? You multiply the sides by themselves, right? Because it's normally, like for a rectangle, length times width. But if they're the same value, you're just multiplying that side by itself. Do you guys agree? So it'd be 6 times 6. What's 6 times 6? 36. So all I'm doing is I'm saying the volume is 1/3 times 36. And then what was the height? Times 12. Plug it into your calculator, and you should get that your volume is 144 centimeters cubed. That's it. Go ahead, Christian. It was fine? Talk to me. What questions do we have? Are we okay? All right. The next one? Yeah.
How do you put 1/3 into the calculator?
So you can do, in parentheses, you can do 1 divided by 3, Hannah. Or you can take whatever your values is, so you can multiply the 36 and the 12 first, and then divide it by 3. Because multiplying by 1/3 is the same as dividing by 3. Okay? Good question. Next one, we're just going to see a similar pyramid, but now the base is not a square. What is the shape of the base now? Oh, you have a professional. All right. So we're working on this next one, guys, and we need to find the volume of the triangular pyramid. So what is the shape of the base? A triangle, okay? So we're using the same formula. Volume equals 1/3 capital B times H. Do we know the height? What's the height of the pyramid? 7. So this is 7 feet. But our base is changing. Our base is no longer a square. Our base is now a triangle. What is the area for a triangle? 1/2 base times height. So capital B is going to be 1/2 the base of the triangle times the height of the triangle. Hayden? So the base area is going to be 1/2. What is the base of the triangle? Well, what's just the base of the triangle? The base length. The base is 3? The base is 4. The height is what? 3, okay? Guys, remember that height is going to be, usually it's in red, it's going to be that length that's perpendicular to the base, right? From the top of the triangle down to the bottom. So we multiply those. What's 1/2 of 4 times 3? So the base is 6, and it's feet squared. Remember, that one's an area. That is not our volume, though. How do we use that to find our volume? Plug it in for B. Okay, so we're going to plug it in for B. We already knew H. H you guys said was 7, right? So now plug it all in. It's going to be 1/3 times 6 times 7. What does that give you?
14 feet.
14 feet cubed. Okay, so guys, compare this one to the previous example. What was the only difference between the two problems?
One square.
One had a base of a square, one had a base of a triangle, right? So this 1/2 was super important, right? Because when you're dealing with a triangle, the formula is 1/2 base times height. You have to remember that, okay? All right, talk to me. What questions do we have on this example? All right, the next one is also a triangular pyramid, but now we have the volume. What are we missing in this example? The height. So now we're missing the height. So let's write our formula again. It's volume equals, who has it memorized already? Very good, 1/3 capital B times H. But now we don't know the height. Do we know the volume? Yeah, it's 24. And can we figure out the area of the base? How? 6 times 3 is not going to give me the area of the base. 1/2 6 times 3. Why is it 1/2 6 times 3? It's a triangle. Very good. Okay. So our base area is going to be 1/2 6 times 3, which is actually just 3 times 3. Do you guys agree? Which is 9. So watch this. Plug in everything you know and see if you can solve for the height. So we've got 24 was the volume equals 1/3 times the base, which was 9 times the height. All right. What can you do to solve for height? Nick?
You multiply 1/3 and 9 and 3 and divide by 2.
Very good. 24 equals, thank you, 3h, because 1/3 of 9 is 3. Then Nick said divide both sides by 3, and you get that your height is 8. Now, we need to be very careful here when we're talking about units for height. What are the units for a height going to be? Meters, meters squared, or meters cubed? Meters. Why don't we square it or cube it? It's not area or volume. It is a one-dimensional length, okay? It's the height of the figure. You with me, Bryson? Are you sure? Okay. Must be the lighting. All right. Any questions on example 3? Waiting. What happened to the 6 feet? What? You mean 6 meters? Yeah. So that I used in my base formula, right? 1/2 times 6 times 3. Half of 6 is 3, so I'm multiplying 3 and 3, and I got 9. Cool? Yeah. All right. All right, so guys, we can also apply those properties of similar solids, their volumes, right, which are proportional by the scale factor cubed. We can apply that to pyramids, okay? So if we're starting with pyramid A and pyramid B, we know that they're similar. Sophia, when I see that word similar, what letter am I going to write down? K. And K represents the? What does it represent? The scale factor. Very good. Okay. We did it last lesson. Where were you? Okay. So our scale factor, remember, is you put 2 of the sides over one another. Okay. What 2 sides do I know in these pyramids? Yeah. Yeah, the 6 and the 8. And those represent what? What dimension of the pyramid? Are they both the height? Yes, okay. So, which one goes on top? 8? Do I get to decide that? Yes. But I have to put what on that figure? An n. A numerator and a denominator, okay? So I'm going to put 8 over 6 and leave it like that. You can simplify it. What does it simplify to? 4 over 3. Very good. Can that reduce any more? No. Do I use 4 over 3 or do I do something else to it? So I do 4 over 3 equals 96 over v, the volume of the other figure. German. You cube the 4/3. Why do I cube it? Why do I cube it? But what are we comparing here? Volume. And volume is how many dimensions? 3. Okay, it's 3-dimensional. So we have to cube our scale factor. What is 4 cubed? 64. What is 3 cubed? 27. So our new ratio is not 4 over 3, it's 64 over 27. So we put 64 in the numerator, we put 27 in the denominator. All right, who remembers how to solve this? There's not enough time. What? Very good, Byron. So I cross multiply. What's 64 times v? 64v. Someone take out their calculator. What's 27 times 96? 2,000 what? 592. You sure? Yeah, you're right. Okay. I'm still solving for what? Volume, right? How do I solve it? Divide by 64. Did you get 40.5? Yay! Volume equals 40.5. Why am I losing a point right now? I didn't put units. What units does it need? Meters cubed. We Gucci? Talk to me. Questions? How many people, raise your hand and be completely honest with me, you're going to forget to cube the scale factor? 100%? It's going to happen, okay? But I would prefer it happens when? Now, so you can learn from it, right? If it happens on the test, are you going to have a chance to fix that? No. And if you Google all of the answers to big ideas or you get them from a friend, are you making that mistake on your own? Unfortunately, no, okay? Unfortunately, no. All right. Guys, one more question. Last example, we have a composite solid. So it's just like the warm-up, except the top piece is not a cylinder anymore. What's the top piece? It's a pyramid. Okay, let's do it. So let's label them figure 1 and figure 2, okay? Which one do you want to start with? Sure, let's do figure 1. What shape is figure 1? It's a prism. How do you know it's a prism? Two bases. Very good. So the volume for a prism is what? 1/3 BH? No. Just BH. What is 1/3 BH? For a pyramid. Very good. Okay. So what's the area of the base? What shape is our base down here? It's a square. Very good. How is it a square? Very good. It has congruent sides and a right angle. How do you find the area of a square? Base times height. So 6 times 6, which gives me 36. So I'm going to say the volume of this prism is 36. What's the height of the prism? It's also 6. What's 36 times 6? 216. Am I done with the volume of the prism? I'm not? Of the prism, meters cubed. Thank you. Is that the volume of the whole thing? No. What portion am I missing? The top, right? And the top we agreed was not a triangle, it's a pyramid. So the volume of this pyramid is 1/3. It is not the same thing, Dylan. 1/3 base times height. Do you guys agree the base of the prism is the same as the base of the pyramid? So can we use that 36 again? Sure. So we're going to say volume equals 1/3 times 36. What's the height of the pyramid?
Wait, you divide it by 1/2.
No, because see how the base is still a square?
Yeah.
If that base was a triangle, then we would divide it by 2. Okay? Good question. What's the height of the pyramid, guys? 6. So now do 36 times 6, but then divide it by 3, 72. Neither of these answers are my final answer. What's my final answer? Very good, Dylan. You add them together. So we're going to take 216. We're going to add it with 72. That should give me my volume total. And that should be 288 meters cubed. We're done. You guys rock. Turn in your notes.